Hey guys, welcome back to Unshackling Sudokus and Puzzles. Today's video will be on a Product Sandwich Sudoku created by Kumaresan. This Sudoku is also present as a variant in the ongoing Math Variations round at Logic Masters India. The contest is a part of Sudoku Mahabharat. If you want to try the contest out yourself, you will find the link to the contest page in the description of the video. The Sudokus will surely be fun to solve. It is a 90-minute contest, so if you are free and can manage the time, do try to give out the contest. It will be excellent to solve. And this particular Sudoku is a high pointer in the contest, and we thought of making a video today. So if you want to try out yourself, the rules and the solving link is in the description of the video. Please try it out and come back and watch the video. The rules of the Sudoku are classic rules apply. Then clues given outside the grid are the product of the digits between 1 and 9 in the corresponding row or column. So many of us might have seen what a sum sandwich Sudoku is. When you sum up the digits between 1 and 9 in the corresponding row or column, they will give you the total which is given outside. So here for a difference we have product. So you have to multiply the digits between 1 and 9 in the corresponding row or column, and that is given outside. So you can use the clue as reference and continue this solve. So this seems to be a very interesting one. And if you haven't yet subscribed to the channel, please check out the videos that we have been posting. I'm sure you'll love them, and consider hitting the bell button and subscribing to the channel. We'll really appreciate if you subscribe to the channel. So having said that, we'll start the Sudoku. So in this Sudoku, this type of variant, it often helps if you mark cells which cannot or can contain a 1 or a 9. So that will help you in the solve surely. So for example, if you look at this 21 column, the only way to satisfy 21 is 3 multiplied by 7. There is no other way. So you can highlight these cells which cannot take a 1 or a 9. So we know that 3 and 7 will take at least 2 cells, and that is going to be either this side or this side. So both of these cells can't take a 3 or a 7, and that gives us a 1 either here or here. Let me use a blue. So either in this cell or this cell. So we can be sure that even these cells are not 1 or 9. So I highlight 1 and 9 using red. So 1 is either going in this cell or this cell. And also using classic, 7 must be in one of these cells. 7 can't go here obviously. 7 must be in one of these cells. And which means that 3 must be in one of these cells to satisfy the 21 clue. If 7 goes here, then 3 goes here and 1 comes here, and similarly if 7 is here, 3 goes here and 1 comes here. So we have started. So let us now look for cells which we can eliminate using the same way. So maybe let us look at smaller clues, a 30 clue maybe. So 30 we know that is either 5 multiplied by 6 or 5, 2 and 3. There is no other option. So can I have a 1 or a 9 here in this cell? So if I have 1 and 9 here, then 6 surely becomes part of the 30 products and sandwich clue. But we know that when 6 is part of that, the only possible combination is 5 multiplied by 6. But that is not going to happen because a 5 is here. So this cell has to be a green. So can row 2 column 8 be 1 or a 9? So if I have a 1 and 9 here, then I must surely have the 5 here, but 5 is also ruled out. So this cell is also not going to be a 1 and a 9. So I can mark that as green. So I can have the 1 and 9 here and put the 5 here and again 1 and 9 here. So let us see. And 1 and 9 can be eliminated here, right? Because a 7 cannot be part of the product clue here. 12 is the outside, 7 is not a multiple of 12. So you can mark that as green. Smaller clues, I am looking for smaller clues maybe. So this appears small, 24. Can you have the 1 and 9 here? So 24 requires minimum 2 digits, 3, 8 or 4 multiplied by 6, or you can split that further. But we will definitely require 2 digits to satisfy the 24. So this is not a 1 and 9 because 7 becomes part of the 24. And similarly for the same idea, this is not 1, 9 and this is also not 1 and 9. So all these cells can be marked as a green. And we know that this requires at least 2 cells. So if I mark this cell as red, then I need to have the red cell here, but this is a 7 given, so this is also not red, so this becomes green. So I have at least 1 of 1 and 9 here and 1 of 1 and 9 here. In fact, exactly 1 of 1 and 9 here and 1 of 1 and 9 in these two cells. We are not sure which cell, but one of these two cells will take a 1 or a 9, and similarly one of these two cells will take a 1 or a 9. Okay, so let us continue now. So if you look at 840 clue, so always when you solve a product sandwich Sudoku, remember to split the outside clue into multiples, into prime multiples preferably. So you know that a prime multiple cannot be factorized further. So if you reduce the outside clue into prime multiples, that really helps. So for example, if you look at 840, we know that 7 is a multiple of 840 and 7 is prime. So we know for sure that 7 must be inside the product sandwich. So which means that to enclose the 7 inside, you need to put a red cell here, right? So this becomes 1 and 9, and for the 840 will require at least 4 cells, right? Because 7 multiplied by 120 will give you 840, and 120 can be factorized further into 5 multiplied by 24, and 24 will be factorized further into 2 digits at least. So which means that 7 multiplied by 5 multiplied by 24 gives you 840. So we will require at least 4 cells inside the sandwich. So which means that none of these cells can be red cell. And what is the maximum number of cells that you can put inside? That is 5, because 7, 5 and 24 you have. 24 can be factorized further into 3 and 8, and 8 can be factorized further into 2, 4. So if you write those digits here, for example, so 7, 5 and 24, right? I'm factorizing 24 into 3, 2 and 4. So you can have maximum 5 digits inside the sandwich in this column 4. So which means that you cannot have a red cell here, for example, because that would put 7 cells inside. Also you can't have red cell here, that would put 6 cells inside. So both of these cells are not red, so they would have to be a green. So you have the red cell either here or here, right? Only 2 possible options, depending on whether it is 7538 or 75324. So if you look at this box carefully, we have marked both the red cells, so these cells would be green. And if you look at this box, box 2, for the 60 clue, I will need at least 5 multiplied by 12, right? So I will need at least 3 digits between the sandwich crumbs. So I can't have both of these cells as 1 and 9. So I have only 3 cells left inside. So this cell surely has to be a 1 or a 9. And one of these cells would have to be a 1 or a 9. And that removes the red cell from here, so that becomes green. So I get the red cell here, that removes the red from here, so this becomes green. So I can mark some 1 and 9s inside the grid now. So this is 1 and 9, this is 1 and 9. So, and this is 1 and 9, this is 1 and 9. So I'll remove the corner pencil mark. This cannot be a 9, so this would have to be a 1. And which means that I can place the 3 and the 7 inside this column. So I will remove the corner pencil marks from there. Okay, that's a 3, that's a 7, there is no 7 here. Okay, and now 24 is either 3 multiplied by 8 or 4 multiplied by 6. So which means that these are the only possible options for us. 24 can be factorized further too, but we have only 2 cells between 1 and 9. That's why it's only 3, 8 or 4 and 6. Okay, so now let us continue the Sudoku. 9 must be in one of these cells, right? So that may be useful later on. And now if I look at this cell, 8 clue, there can be a maximum of 2 digits in the between the sandwich crumbs. So because 8 can be factorized into 2 and 4, 2 multiplied by 4, and you cannot factorize anything anywhere further. So which means that, so you can't have the sandwich crumbs 3 cells apart. So none of these cells can take a 1 and 9. So you can have the 1 and 9 here. This cannot be a 1 and 9 obviously. So either this is 1 and 9, this is 1 and 9, or this is 1 and 9. Only 3 options left. So, and for the 12 now, I marked one of the crumbs already. So I need two digits at least for the 12. So this is not a 1 and 9. Both of these cells can't be 1 and 9. And I can maximum 2 into 6, right? Or 3 into 4. Okay, you need to have exactly two digits between them, because 12 cannot be factorized into three distinct digits, out of which one is not a part of. So this has to be a 1 or a 9, right? Because if you place the 1 and 9 here, there is no way you can satisfy the 12. So remember that 1 and 9 are not part of the factors. That is an important thing to remember. So which means that I can place the 1 here now, 9 here, the 1 here, and the 1 here. And now this is going to be either 2, 6 or 3 multiplied by 4. These are the only options left to us. So how do we continue now? I can still put the 9 here and have the 2 multiplied by 4 here, okay. So this column has suddenly become more interesting, guys. So if you look at this column, none of these 4 cells can take a 1 and 9, and we know that 30 will take at least 2 cells inside, so that cancels out this cell. So this is not a 1 and 9, because that would force a maximum 1 and 9 here, and you'll get only 1 cell inside, or here and you'll still get only 1 cell inside. So this is not a 1 and a 9. So which means that out of these cells, one would have to be red and the other red has to go here. Beautiful, guys. That's beautiful, really. So this has to be a red cell, and we require at least 2 cells, and we have already got a 6, which means that 6 multiplied by 5. There is no other way to factorize the 5, so this has to be a red. This is not a red, so that becomes a green. So I can place some more digits now. So this is 1 9, this is 1 9, and that becomes a 5. And now let us look at the 60, because we have got one of the sandwich crumbs. So this is a green, that has to be a green, and 4 multiplied by 3 is 12, and we need 5 more, so this has to be a 5, and that becomes a 9 now. That becomes a red cell, and it would have to be a 9. That gives you a 1 here and a 9 here. So 60 is done. So let us 60 is done. 24 is partially done, so maybe let us not share that for now. So 21 is done. 12 is also partially done. 30 is done. Okay, we have still quite a few clues left to see. Maybe 840, we can come back to 840. So one more thing that you can do while solving a product sandwich Sudoku, this will also be really helpful. Please listen carefully to what I say now. So we know that the sum of the digits, the product of the digits between 1 and 9 is maximum 2 multiplied by 3 multiplied by 4 up to 8. And if you multiply that, you're going to get 40,320. So when you have the outside clue as very large, for example, this case 1680 or 840, maybe 3-digit or 4-digit outside clues, you can use the idea that the maximum product possible inside is 2 multiplied till 8, and that will give you 4320, and you can divide that by the outside clue and check what is the value, and that is the product of the values which are going outside the sandwiches. So that you can use to your effect, for example, maybe. So here if you divide 40,320 by 840, you will get something, and that can be factorized here, that can be placed into these 2 cells. But we have already written the factors here, right? If you have 5 digits inside, this is the only possible value for 840, 75324. There is no way you can factorize any of these further, and you need to have all these 5 digits 1 2 3 4 5. So which means that, so you will get 6 and 8 into these 2 cells. Now if we use the idea that I mentioned a little earlier, you will see that 16320, 4320 multiplied by 840 will give you divided by 840 will give you 48 again, I think, right? Yes, because we are multiplying all the digits from 2 to 8, and we have removed these 2 cells, right? So this is not going to become part of the product. So you take the product of all the digits and then divide by the outside clue, and that gives you the product of the outside cells. So this is an useful technique, and you can try to use this while solving product sandwich Sudokus, and also in the contest 1 3 5 7 9 6 and 8. So these 2 cells will be 2 4. Okay, so they are getting some digits now. So we haven't yet looked at this cell at all. Maybe let us look at this 360 glue because it's quite a huge sum, quite a huge product. So this glue will be helpful because we have placed one of the ends of the sandwich, which means that all these cells must be green, and I obviously cannot have one here, that will be too far away, right? So if I place the one here and you multiply 1 2 3 4 5 6 6 digits, that will surely take you above 360. So you can make a mental multiplication. 2 3 4 is 24, and if you multiply that by 5, that gives you 120, and if you multiply that by 6 with 5 digits itself, we are getting a product more than 360. So which means that one has to be here, one cannot go here, right? So this would have to be a 1, and which means that for 168 I will require at least, let me remove these cells now, not going to help. So 168 will require at least 3 digits, right? Is 7 a factor of 168? 7 2s are 14, so 24. 7 multiplied by 24, yes, and 24 needs to be factorized further into 2 cells, so you need at least 3 cells to get to the product. So these 3 cells cannot be 9, and which means that 9 must be in one of these cells. So one of these cells would have to be red, not sure which one, and none of these cells can be red, all these have been marked. And I know that for the 2 clue, there is only one possible way to satisfy, 1 2 and 9 or 9 2 and 1. So either way this cannot be red clue because that would force this as red, but this is not a red. And continuing further, I can have this as red, this as red, this as red, this as red. Can I have this as red? No. If you have this cell as red cell, okay, it's already eliminated because we have 1 9 here. So none of these cells can take a 1 or a 9. So we have this option for 1 and the 9, or this option. Only 2 possible options in that cell. So 1 9 2 or a 9 2 and 1. Okay, both of these seem to be valid, and this is not a red because we have 1 9 here. So one of these cells would have to be a 9 and one of these cells would have to take a 1. Okay, using classic we get the 1. This would have to be a 1, and 9 must be in one of these cells. Let me make a corner pencil mark. And 1680. So here we can make use of the fact 40,320 by 1680. Probably it will be easier to work out if you have a pencil and solve it on paper, but working out mentally is difficult. So I'm going to try to factorize this further and see if I can solve it. So 1680. So 5 is surely a factor of that, right? 5 is definitely a factor of 1680, and 336. Okay, 5 multiplied by 336. Okay, 336 you can factorize further. Is 7 a multiple of that? 4 7s are 28, 8 7s are 56. 48. Okay, 7 again, 5 and 7 are surely a factor of that, and you have 48. So I will require at least 4 digits because 48 is 6 multiplied by 8. 1 2 3 4. I have the 4 digits already, but you have the 6 outside, so which means that 6 has to be factorized further. So if you multiply all these digits, you will get 1680. 48 multiplied by 5 is 240. 240 multiplied by 7 is you will get 1680. So I know that 6 is not part of the product sandwich, so 6 would be factorized further as 2 and 3, which means that it needs to have 5 cells apart. So this is not a 9, that would have to be a 9, that becomes red, and rest of the cells become green in that column. So the only way to factorize 6 is using 2 and 3. So this becomes 2 3, which means that I need to have the 4 outside. So these cells must be 2 3 5 7 8. That will give you a product of 1680. Now if you had used the idea that I said, divided in 40,320 by 1680, you would have got 24, and straight away we could have written the 4 here, right? That would help, really help. I mean, straight away we could not have written because straight away we could have written because you can't factorize 6 further, right? So we could have written the 4 right away. So let us continue the Sudoku. Okay, you have the 40 here, so we need at least 2 cells. Oh, this is not, and obviously 40 is 5 into 8 or 5 into 2 into 4, so it cannot be 4 cells away, so you cannot have a 40 here. So which means that I have the 1 here or here, only 2 possible options. Okay, Okay, now if you look at column 2, one of the options for the 2 is ruled out, so the only option left is this. So this would have to be a red, and that would have to be a red, and which means that I get a 9 here, a 1 here, and a 2 here. And that gives you 8 right away because this is 8. And we know that 5 has to be in row 8, only one possible option for 5, this has to take a 5. And 8, if you look again in row 8, it has to be become part of the 24, so this has to be 3 and 8. And that gives you 4 6 here and a 3 7 here, these cells, classic. And now 1 has to be here, which means that this would be a 5 8 for the column to satisfy this, and that resolves this 5 and 8. So we are getting digits thick and fast now. So these two cells will be 2 4 6 for the column, and for row 3 2 6 and 7 or the possibilities. You have a 2 here, so this is not a 2. Okay, so let me highlight some more clues. This is done, this is done, this is partially done. Okay, I don't see how this could be helpful, so I'm going to shade this as well. So all these are done, this is done, this is not done, this is done, this is done. Okay, partially done, I'll highlight that as well. So this clue is of interest here. We haven't yet looked at this at all, so let us see if that is helping us. Okay, so I'm using some classic here, 2 4 7 2 4 7, 1 5 6 9 and 3 and 8, so these two cells will be 2 4 7. So I'm going to factorize the 168 now, guys, because this seems interesting. So 168, can a 7 be part of that? Yes, 7 is obviously multiple of 168. So 7 into 2 and 24. So 738 or 746, or I can factorize this further and this further. Okay, that is a little bit complicated. Okay, 746 is ruled out because you have a 4 6 here, right? So you can remove this option. So now it's 738 or 7324, 732 and 4. Is there any other option? 746, can it be split further? 7423. Yeah, it's the same as that. If you factorize 746 further, you will get still the same possibility. So these are the only options left for 168. It's 738 or 7324, and 738 is ruled out immediately. So this has to be the option. 7324. So I'll need at least 4 digits. I mean exactly 4 digits. So which means that this is a green, and that has to become my 9. And these cells must be 2 3 4 7. I can remove them and place 2 3 4 7 right away, and that gives a 6 here and a 4 here. So this is not a 4, that is not a 3 4, that is not a 7. Okay, this is an excellent Sudoku, guys. It requires you to sweat till the end. I'm not a Mac wizard or something. I'm quite poor at math, so maybe that's why I'm taking this much time. 6 8 9 1 and 7. So these cells will be 2 3 4 and 5. Okay. 360 clue, right? Maybe that would help us because we have removed the 8 outside. So let us factorize 360 further. I'll require a 5, and 5 multiplied by 72, right? Yeah, 5 multiplied by 72 and 3 multiplied by 24, because 72 is 3 multiplied by 24, and 24 is either 3 into 8 or 4 into 6. 3 into 8 is ruled out now. So which means that it has to be a 4 into 6. Can I factorize this further? This can become 2 and 3. Not possible because you have only 4 cells exactly inside. So this has to be my combination. There is no way you can combine any of these 2 digits and get a different combination. So this would have to be 3 4 5 6. Right? I am going to write the digits here. This is 3 4 5 6, which means that becomes a 2 and that becomes a 6. Which means that this would have to be a 7, 3 4 5 6, 1 2 8, 7 and 9. Right? And now this is not a 5 6. 5 6 7 9 1 4 8. 1, 4, 6, 5, 7, 9, 2, 3 and 8. So this has to be a 3. These two cells will be 2, 8. And this has to be my 4, 5, 6. And this has to be my 2, 3, 8. And you have a 2, 8 pair. So that gives a 3 here. This would be a 2, 8. And which means these cells will be 3 and a 5. That gives 5 and a 3 here. That is a 2 and 4. And that is a 2, 4 and 7. 2 is ruled out. This would be 4, 7. Okay. So we are in the finishing stages of the Sudoku. Hopefully we complete it. So I know that the 12 cannot take a 5. So this is 4 or 6 and correspondingly this would be 3 or 2. Okay, 8 is not here. The only possible cell left for the 8 is here. So that's 8, that's 2. 2, 3, 9, 1 and 7, 6 and 8. So we need to have 4, 5 here. That's a 5. That's a 4 and a 5. That's not a 5. That's not a 4. So you have a 2, 3, 7 triplet, 1, 4, 5. So which means that 6, 8 and 9 or the digits. You have 8 here. So that's not 8. That becomes 8. 1, 5, 7, 9, 4, 8. So these would be 2, 3, 6. 3 gets removed from here. So even this is also done, right? So I don't have the outside clues helping me now. So I need to focus on classic. Okay, 5, 5. That gives me a 5 here. That would be a 5. 7 is not here. 7 is not anywhere here. And there is only one cell left for the 7 in column 7. So that would have to be a 7. That means that is not a 7. That's a 2, 6. So 7 goes here. 2, 4, 5, 7, 1 and 9. So this would be 3, 6 and 8. That would be 3, 6 and 8, not a 6 because 6 is here. That's not an 8. 8 goes here. So 3, 6, 6, 8, 6, 8, 3, 8. You have a 3, 8 pair. 1, 5, 6, 9. So this would be 2, 4, 7. No 7, 2, 4. 2, 4 pair. Come on guys. Look how the classic part is driving the Sudoku now. It's not like after we completed the variant, it's just writing the digits blindly. So now the classic part is really helping us now. 1, 5, 7, 2 and 4. So remaining digits must be 3, 6, 8 and 9. So you have 8, 9 here. So that becomes a 3, 6. And you have 3, 6 pair. And that should be the final nail in the Sudoku. Hopefully. So that becomes a 7. That becomes 2. That becomes 4. 7, 4, 4. And that's not a 4. This is a 2, 7, 2, 7 pair. So that gives you, oops. I've made a mistake guys. I've made a mistake. I need to retrace my step back. What did I? Okay, I had placed a 4 here, right? This should have been a 2. Thankfully, if this were a 4, there is no 4 here. So this is a 2. That becomes 7. That becomes 4. That becomes 7. That becomes 3. That becomes 2, 6, 3, and 6 and 4 gets resolved, and 4 and 2 gets resolved. That would have to be 2 for the box. That resolves this 2, 8. That gives you a 6. That is already resolved. That resolves this 6, 9 pair, and you need to have a 3 here. 3, 5, 6, 2, 4, 8, 1, 7, 9. Okay, so this would be 8. That would be 8, 6. That would be 6, 3. And 2, 3, 5, 7, 8, 1, 4, 6, 9. That would be a 9. And we can resolve this 8, 3 pair and the 4, 7 pair. So, and that completes this really excellent construction, guys. Excellent construction. So, to summarize the tricks that you need to solve the Sudoku are, always remember to factorize the outside clues into prime multiples preferably, and also remember that the maximum possible product inside the sandwich crumbs is 2 multiplied till 8. That gives you 40,320 if I'm not wrong, and you can use that to your advantage when you have the outside clue as a 4-digit or a 3-digit number. So you can use this to your advantage and try to ascertain what are the digits which go outside the sandwich. So that will be really helpful in the Sudoku. Hope you guys enjoyed watching me solve this Sudoku. We hope to be back again with a video. Bye bye.